All right, so we're getting back into statistics here. Last time I recorded was Monday night. It's now Wednesday morning, 8:43 a.m. I got to be on the road at like 10 a.m., 10:15 a.m. So we got an hour and a half. We did random variables and we did developing discrete probability distributions. And just as a reminder of what is that stuff, discrete probability distribution for a random variable. So the discrete probability distribution, like this is one of my contentions with statistics. Up here they call it a discrete probability distribution, and then down here they just say, they say probability distribution. It's the probability distribution. So I think it's better like that. A discrete probability distribution. A discrete probability distribution for a random variable describes how probabilities are distributed over the values of the random variable. I just feel like, in statistics, things aren't explained that well. Like statistics doesn't come naturally and fluidly for me. It takes a fair amount of repetition and pounding to get it into my head. And that's where that analogy that learning statistics is a little bit like learning a foreign language. In that, like, if you're in China, you're learning like Chinese, you'd be like, how do you say sprinkled donut again in Chinese? It's like completely different. And it's like you almost kind of don't have a frame of reference. Like this isn't like language that's normally used in our culture, discrete probability distribution. It's kind of clunky and awkward. We're not familiar with it. It's a little bit like Chinese to me, and it takes takes some repetition to get it into the brain. So discrete as opposed to continuous, and a probability distribution, it's a distribution of all the probabilities. And a random variable, it's just we're dealing with a variable, and it could randomly be any one of several different variables. And just to refresh our memory what that looks like, here's the variable. On any given day at DeCarlo Motors, it could randomly be one of these variables. And then we have, and these are discrete variables. You're only selling whole numbers of cars. It's not continuous. You're not selling fractions of cars. And so, right, here's our variable, it's discrete, and here's the probability distribution. So this is a discrete probability distribution, ladies and gentlemen. And here is the probability distribution. So if we have this variable on any given day, right, we could put it into this function, that variable into this function, and it'll produce this outcome. It'll spit out this outcome and tell us the probability of selling 2 cars on any given day is 0.24. And so that's a discrete probability distribution here. For these variables here, which randomly you could have one of these variables on any given day. It's kind of an awkward, clunky way to say that, here's like the easier way to say it, like, hey, this car dealership might sell between 0 and 5 cars, and here's the probability associated with each of those things occurring. And I'm hesitating there with my language because I was going to say each of those events occurring. So I guess you could say an event would be, the probability of the event would be like, hey, I sold 2 cars. And this is the entire sample space, right? And so that's the whole sample space. You could sell either 0 or 1 or 2 or 3 or 4 or 5. That's the whole sample space. And the event is a subset of the sample space. So if I want to know the probability of the event, the subset of the sample space, the event that 2 cars are sold, the probability of that is 0.24. So that's using this terminology here, event and sample space. And then just to remind ourselves, an experiment is a process that generates well-defined outcomes. An outcome is a sample point, right? These are all sample points. This is our sample space. And then, and this is the sample space. It's all possible outcomes. And an event is a subset of the sample space. So it takes a while. It's Chinese, man. It takes a while, repetition, to get familiar with the lingo here, the language that's being spoken in statistics. So random variables, discrete probability distributions, and now expected value and variance. We're going to do that in the next video because here you go, a little insight into the magic of Hollywood. I've actually recorded this videos. Where is it? Where's my work for today, man? So you can see here, 8:28. This is the 4th time I've recorded this intro video, and it's still in process. And I did one for 1 minute 15 seconds, one for 38 seconds, one for 2 minutes and 53 seconds. And now this video here is all the way at 4 minutes and 36 seconds, because the first 3 times or whatever I tried to say all this, I was like, I got the terminology wrong, and I was just like, let me just redo it so I could use the right words so it all makes sense. All right, so I'm gonna end this video because it's in the can, as they say in Hollywood, and in the next video we're gonna jump into exploring the next stuff on this list. I'm just getting my talker going. I know it's kind of monotone and just like nah, 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 because a lot of my processing power in my head is going towards actually saying things correctly and wrapping my head around this subject, which is a little bit convoluted in my opinion and overly complicated the way they've made it. And the people who put all this field together, I don't feel like they were that good with English. Otherwise, they would have been able to explain it more clearly. And that's why I think that statistics has a little bit of an inferiority complex. But if we understand it and clearly explain it and don't overcomplicate it like the big city folk, then I think we're going to be able to make sense of it. So that's my goal here. But a lot of my processing power is going to just understanding it and explaining it as clearly as I can. So when doing that, I get into a little bit of an autistic kind of thing where I'm just like da 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 da, and it's not quite as presenting oriented because that takes processing power too. Random thoughts there for you. See you in the next video.